This is chapter 7-1, rigid motion in a plane. Please copy your cuts. All right, to begin here, we're going to look at some things that we talked about earlier in class. We talked and we looked at some different things as the word flip. Okay, so let's see here. If I have this first image F here and I decide to flip it over the blue line such that it now looks like this here. So I took, this is the first, the pre-image here, and I flip it over the blue line and now it looks like this. Well, the proper name or terminology for a flip is actually called a reflection. So we will not say flip, we will call it a reflection because that is the proper name, reflection. The next term we looked at is if I have F here and I decide to turn it. When I turn it, as I'm turning it, it will end as an image that looks something like this. Okay, so this is my first pre-image here, and then we have the image. The proper terminology for a turn is actually called a rotation. Okay, so we don't call it a turn. The proper name is a rotation. Next, the next one we have is F. If I move it or slide it from here to there, that's actually called a translation. We don't call it sliding the image. Okay? It's called a translation. That's the proper terminology. So we have reflection or the flip, the rotation is the turn, and the slide is the translation. Moving further. All three of those moves are what we call maps. Are mapped or moved by a process called transformations. Transformation occurs when you map, or in other words, you move the original figure. So I'm moving or sliding the original to this image here, okay? And that's called mapping when I move it. A rotation, a translation, or a reflection is being, an object is being moved or mapped, okay? And that process of actually moving that object is called a transformation. And again, transformation is just going to occur when you map or move the original figure to a new location. Okay? The original figure is actually called the pre-image. You've heard me state before, but I didn't give it an official name. And the new figure, or the second figure, or the one that's been mapped or moved, is called the image. So here is the pre-image, and because it was moved or mapped by translation, this second one is called the image. All right, so here we have, this was our first one when we did the reflection. On the left was the pre-image, and on the right is the image. Okay? Whenever a transformation occurs, and the image and the second figure have exactly the same length, same height, depth, the angles are the same, the distances between from here to there, let's say I'm looking at the distance from here to there. If the distances are exactly the same from here to there as well as here to there, if everything is the same other than the direction that it's facing, what we are going to now have is we're going to say that the pre-image and the image have isometry. Okay? When the image and the pre-image are exactly the same size, same measure, everything exactly the same, it's called, or it has isometry. Okay? Transformations that are isometric, again, are now called rigid transformations. When I have a transformation that's isometric or isometry, they have isometry, they are called rigid transformations. All right. Again, the pre-image was on the left when we did this reflection. The image is on the right. Because the image is exactly the same exact size, the same exact shape, and it has the same exact dimensions as the pre-image. So the image has the same exact height, depth, length, shape, size, angle measures as the pre-image. Then the image has isometry. Okay? We're going to look at a few pre-images and draw some images. Let's look at the first. Let's suppose I have this funny shape here. Okay? We're going to flip the pre-image AB over the x-axis. Okay? And name the new image prime, B prime. Okay, so we're going to take the pre-image AB and we're going to reflect it, okay, because we don't want to say flip, we actually want to call this a reflection, and we're going to reflect it over the x-axis. When we reflect it over the x-axis, the new A is going to be called A prime and the B will be called B prime. And what that looks like is this here. Okay, if it were a piece of paper, I would fold on this line, and A corresponds to A prime and B corresponds to B prime. Okay, the second image, or the image I should say, the variable names are generally called the prime. So this is down from A, the new image is called A prime, from B to B prime. Right? Let's look at another. Let's say I ask you to turn, and we call that turn. We actually don't want to say turn. We want to call that a rotation. We're going to rotate this figure A, B, C, D, and name that new image A prime, B prime, C prime, D prime, E prime, such that it would look like this here. So as I rotate, and it looks like well, it doesn't matter, you could go clockwise or counterclockwise. I haven't given a specific direction. You can see A prime is here, B prime is there, C prime, D prime, and E prime. Okay, and it looks like apostrophes. That's how you call your primes out. These are apostrophes for you to make them prime. All right, and next item of business. I'd like for us to look at an example. Okay, come on. All right, so a naming a transformation. Use the graph transformation that you get ready to see. Name and describe the type of transformation that it is. And remember, the types of transformation is a rotation, a reflection, or a translation. Those are the names or motion types for a transformation. Okay? Name the coordinates of the vertices. And the question is triangle ABC congruent to its image? Okay, so here are the two images. The original is here, or the pre-image, ABC, and we know it's the pre-image because there's no prime associated, as it is here. When we look at this, we ask ourselves, what type of transformation is this? Is this a reflection? Is it a translation? Or is it a rotation? Well, to me, it looks like we flipped it, which is called a reflection, over the y-axis. C corresponds to C prime, A corresponds to A prime, and B corresponds to B prime. Now, if I'm on a coordinate graph, I want to know if these two are actually the same exact length. Remember, if the image and pre-image are exactly the same size and shape, that means they have isometry. And to determine that means that the side lengths should be the same in angles. Well, one way to determine if the side lengths are the same is to find out if AB is the same length as A prime, B prime. And you can do that using the distance equation. You remember the distance equation, I wrote AB in here, but this is the distance equation. D equals square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, back in chapter 1. Okay? Well, anyhow, let's say I just want to see if AB is the same length as A prime, B prime. I put in the values here, and I see that B is 1, 2, 3, negative 3, up 1, 2, 3, 4, that's 5. So the ordered pair for B is negative 3, 5, and for B prime I see that I have 1, 2, 3, so positive 3, and then up 1, 2, 3, 4, and 5. Okay? So let's see if they are the same distances. I need to find the ordered pair for A, and it's at negative 1, 2, 3, 4, negative 4, up 1, and A prime here is at 1, 2, 3, 4, positive 4, 1. Okay? And to do that, this page is getting ready to get jumbled up, but I'm quickly advance the slide here. You'll see it. Okay, so this is me showing all the calculations. Yes, it got really busy. Okay? There's our negative 3, 5. B is at 3, 5. A is going to be at negative 4, 1. And then A prime is at 4, 1. Well, I started to find out if AB is the same length as A prime B prime. Well, what did I name my 2's? I let the B's be the 2 and the A's be the 1. Remember, we had to classify which one are going to be your A's and the B's. Okay? So here's our equation for distance. Okay? And if B's are the 2's, that's x of 2 minus x of 1. So the B's will be first. That's going to be, which one did I do here? X of 2 is going to be negative 3 minus x of 1, which is going to be down here, my A's, minus a negative 4. Plus y sub 2, which is my B's, 5 minus the y sub 1, which is the 1. So 5 minus 1, and minus a negative will be plus, so this will be negative 3 plus 4, which is a positive 1 squared, plus 5 minus 1 is a 4 squared, which will give us a 16. So 4 squared is 16, 1 squared is 1. So the square root of 17 is the length of AB. In order for us to say that AB is the same length as A prime B prime, we better get the same exact length for A prime B prime. Now, let's look at the measures of A prime B prime. Same thing, I'll let B prime be the 2's, A prime be the 1's. What's my x of 2? That's going to be my B2. That's going to be 3 minus x of 1, which is going to be my A value 4. So 3 minus 4 squared plus y sub 2, my 2's are the B's. So y sub 2 is going to be this 5. 5 minus, and my y sub 1 is going to be here the 4. So 5 minus 1 squared. And I'm moving fast on this portion because I would hope that you remember distance equation back in chapter 1. Okay? 3 minus 4 is negative 1 squared, plus 5 minus 1 is a 4, and squared. Negative 1 squared is a positive 1, plus the 16. And 1 plus 16 is the square root. It's going to be the square root of 17, square root of 17. And we see that both lengths are exactly the same. So I can mark on here that AB, put that symbol on there, is the same length as A prime B prime. Now that's only one leg. You'd also have to check the BC. It has to be the same length as B prime C prime. Then you'd have to do a third distance equation to check AC, and it needs to match the same length as A prime C prime. Okay? And there's your 7-1 video.